of 90 point. I know I'm going the wrong way. 90 point. Let's do 001. That's what I'm looking for. Okay, just beyond 90, and that should be. Look at that. Negative 57,000. So that's why it's so low down here. It's coming from negative infinity on this side. Okay? So as the function gets close to 90 from the left side, now when you guys get into calculus next, okay, what I'm talking about are limits here. As x approaches pi over 2 from the left side, the value of the function approaches in positive infinity. So this is wording that we'll be talking about a lot in calculus. And as the x value approaches pi over 2 from the right side, so that's going this way towards pi over 2, we're approaching negative infinity. Okay? Okay? So again, this is tan graph, section part 2 video. All right, here's the other way. We made this unit circle really pretty here, okay, but it's a mess. So we talked about graphing the tan, and the second method I want to talk to you about is special angle triangles. So you should have learned these special angle triangles like when you were a little bitty baby, learning math in your diapers and everything. You would have been, maybe if you had good parents, they would have like pasted this stuff on your walls when you were an infant and stuff. Anyway, so you should have been exposed to this for years. If not, however, I'll go over it again. Okay. So on the 45, 45, 90 triangle, okay, does anyone remember what numbers would go on these sides for this basic sort of relationship here? 1, 1, 2. You are very close. This is 1, but I'm afraid that this is not 2. Root 2. Thank you. That's way better. Why is that? Right triangle. Pythagoras' theorem says this. Equals, and then this is going to be the r, or the radius, or whatever this squared, c squared, I guess, whatever. So that's 1 plus 1 equals r squared. R is the square root of 1 plus 1. All right. So yes, 1, 1, root 2. This is trickier. Who remembers the 30, 60, 90? Who remembers those sides? 1, root 3, and 2. Yes, very good. So where does the 1 go? This side, bottom? Yes. Okay. 1 and then 2. So which one is 2? Well, actually, is root 3 smaller than 2? Yes, it is. We just found that out, right? It's 1.7 something. So this is going to be the longest side because it's the hypotenuse. So that's 2, and this is 3. Okay. So you may remember that now that we have it on the screen. But what you may not remember is why this is important. Well, if you remember SOHCAHTOA, okay, probably the most famous memory mnemonic known to mathematicians, okay, SOHCAHTOA, we know that the sine of any angle in a right angle triangle equals opposite side divided by hypotenuse. So the tangent is the TOA part. All right, so tan of theta equals opposite over adjacent. So if we're looking at 45, let's say, remember 45 from your unit circle up here? The tan of 45 should be what? Should be 1. Okay, that's what we determined according to the unit circle. So let's just see. Opposite side of 45 is this one. That's 1. The adjacent side is the one that's very next to that angle, but it's not the hypotenuse, so it's this one. That's 1 over 1 is 1. So that makes sense too, and this is what you've known for years. Okay? So all good, right? Okay? Well, let's skip over to 30. 30 degrees. 30 degrees, opposite side is 1. Adjacent, that's the side next to 30, that's not the hypotenuse, root 3. So tan of, sorry, this was 45 degrees. This is tan of, what was that? Weird. Okay, so tan of 45 is what I meant to put there. Tan of 30 is what we're calculating now, 30 degrees, is 1 over root 3, which simplifies to root 3 over 3. And that should match up with your unit circle. And finally, 60 degrees opposite side is root 3, adjacent is 1. Root 3. Now, does that match up with the unit circle values that we just determined? I hope so. If not, then math is a waste of time. But since it agrees, we all know that math is not a waste of time, right? Okay, good. Some nervous laughter there. Okay. So any questions at this point? Is there anything that you do not understand that I can go over with you? Okay. Okay, on a scale of 1 to 5, right? Well, actually, 0 to 5. 0 is I have no idea what's going on. I've just been too scared to ask a question. But I am seriously on another planet right now. That's 0. So you just throw up a fist at me, okay? I won't take it personally, but it's just 0, no fingers. And if you are at a 5, so if you want to throw up all of your fingers, that's 5. That's the level 5. And that means, Mr. Maxwell, I could just be up there doing your job right now because I know this so well. Okay, so that's 5, total 5. And if you're a 1, please use your index finger, okay? So I don't accidentally get offended by you throwing me one of your other fingers. Okay. All right, ready? I'm going to look around the room right now, and I want you to do that right now. Okay, ready? Let me see. 1, 2, 3, go. Okay, good. I see some 4s. I see some 4s. I see some 3.5. Really? Okay, all right. 3-ish, 2. Okay. All right. So the average is above half, above 3, so that's good. Okay. All right. Now, all right. So page 262, key ideas. There you have a graph, right, of the tan function that we did. And obviously, you want to note that the tan is a periodic function as well. Okay, so it kind of looks like this. That's what we drew. But you have to realize that it goes back the other way, and it repeats itself every pi units. Right? So over and over. See that? Over and over. Now, we are going to work with transformations of tan as well, I believe. No, this. Oh, no. This is your tan graph, okay? Because this is what we just looked at. See this part of it? Right there and there. So I started from here to here. You could look at it another way and say, hey, this looks like one period to me, Mr. Maxwell. That's one complete cycle. Fine. Go ahead. This starts at 0 and goes to pi. All right? This one starts at negative what? Pi over 2 to positive pi over 2. So, yeah. It's repeating. Repeated function. All right. Okay, so the key ideas say that period length is pi units, as opposed to 2 pi for sine and cos, just 1 pi. From start to start, whatever, start to start, or from asymptote to asymptote is only pi units long. Okay. Interesting enough, there are no maximum or minimum values for a tan function because they go up to positive infinity. There is no really end to this, and they go down forever as well. Okay? So there's no max or min. The range, okay, the range is y-e-r. Okay, so there is no limits to the range as well. It can be any y values. But the domain is restricted. Okay? So the domain, and you can write the domain like this. So x is everything but. Okay, so you can write it like this if you want. It can't be pi over 2. Right? You see the pi over 2. And because it's every multiple of pi over 2, you could say this. Plus any multiple of, oh sorry, not pi over 2, but any multiple of pi, right? One complete cycle. Any multiple of that, there would be a restriction on the domain. So that's sort of how you could write your domain for the basic tangent graph. All right? So x-intercepts, that's where the graph contacts the x-axis, and the x-intercepts would be at every multiple of pi over 2. So that would be at, I'm sorry, every multiple of pi starting at 0. So x intercepts at pi plus or minus, really, but plus n times pi. So that means you have, it's at pi plus any multiple of pi, positive or negative. Can I scroll up or down? Do you want me to go back? Down? You want me to go ahead? There we go. That's, my head is blocking your, oh, thank you. Are you saying I have a fat head? Because, no. Oh, you didn't say no right away, actually. Oh, you did. Okay, fine. I won't be mad at you then. I'll try and find something else to be mad at you about, but not that. Oh, okay. All right. What's the y-intercept? Last thing. What's the y-intercept? The y-intercept is 0. See? There's only one y-intercept. It's a function, so there's not multiple y-intercepts. There's just one y-intercept is 0. Okay, so here is the section of the textbook. Here's the key ideas right here that we just went over, guys. And here's the graph. And of course, you may have your graphing calculators for this assignment, which I'll give you in a second. Okay? There you go. No, hopefully not. Unless you just watch these videos over and over again so the views go up. Then you never know. That works? Okay. I'm going to win some kind of teacher award, like getting my kids to do math all the time. All right, so as far as the assignment goes here,
Which I could do it 100 times. I keep on just refreshing the page. Well, I think
okay. All right, 1, 2, 3. Seven. And 9. Okay, there you go. Just those questions for your assignment.